Alright, this is the video for the Qualitative Reactions lab. I'm going to be demonstrating all the different parts of this experiment and pointing out all the observations you should need to be able to complete the lab on your own. In part A of this experiment, we're going to be looking at a piece of equipment known as a Bunsen burner. This is a laboratory device that is used to produce a flame from the combustion of natural gas with oxygen in the air. In this video clip, I'm connecting the inlet hose of the burner to the natural gas, opening the gas valve, and using a flint striker to start the combustion. I then adjust the airflow to get the ideal air-fuel mixture. You can see that there is a nice blue flame. Part B of this experiment will look at the reaction of hydrochloric acid with magnesium metal. We'll use one of these small metal strips in the reaction. I take one of the metal pieces out of the bottle and place it in a test tube. To that same test tube, I add some hydrochloric acid, about 1 milliliter. As you can see, the reaction of these two chemicals produces a large amount of bubbles. This indicates that a gas is being produced. We can test to see what gas it is using a flaming splint. I reignite the Bunsen burner and use it to light a wooden splint on fire. If the gas being produced is flammable, we should hear a pop sound if we use the flaming splint to test it. This test reaction is another example of combustion. In part C, we're going to see if a reaction takes place if we mix together aqueous solutions of sodium chloride and potassium nitrate. Here's the two solutions. I start by adding some of the sodium chloride solution to a test tube. As you can see, it's a clear liquid. If we add some potassium nitrate solution, which is also a clear liquid, there's no evident change. Did a reaction take place here? Think about what kind of reaction can happen if you combine two aqueous ionic compounds, and whether that's possible with these two substances. Part D is similar. Here, we're using the aqueous sodium chloride again, but this time we're going to combine it with some aqueous silver nitrate. I start by adding some of the silver nitrate solution, another clear liquid, to the test tube. I'm wearing gloves because silver nitrate can very easily stain skin if even a small amount gets on you. To that, I'm going to add some of our sodium chloride solution. You can see that the liquid immediately becomes an opaque white color. Clearly, some sort of solid has been formed in this reaction. For part E, we're going to need two chemicals, hydrochloric acid and some solid sodium carbonate. I start by adding a small amount of the sodium carbonate to the test tube. It's a white solid. To that, I add some hydrochloric acid. The shot came out poorly, but you might be able to tell that this very quickly produces a lot of bubbles. We can do another flaming splint test to analyze the gas produced. Off-screen, I light a splint with the Bunsen burner, and we repeat the test. This time, though, putting the flaming splint into the gas produced just puts the splint out. This is a non-flammable gas. Part F is the last experiment we need to go over together. For this, we're going to need some aqueous sodium hydroxide and a few drops of phenolphthalein. Phenolphthalein is an indicator, which means it changes colors depending on its chemical environment. It's not part of the reaction we're going to see, it just tells us whether the solution is basic or not. In a large test tube, I add some sodium hydroxide solution and some distilled water. The water is just to increase the volume to make a later step work better. Then I add a couple of drops of phenolphthalein. You can see the solution becomes a very nice dark pink color. This makes sense because sodium hydroxide is a strong base. Now, I'm going to carefully use the straw to start blowing my breath into the solution. I'm essentially using my exhaled breath as a source of carbon dioxide. At first, no color change is observed, but eventually the solution starts to become a lighter pink color. Finally, it becomes clear altogether. Phenolphthalein becomes clear once the solution is no longer basic. In other words, when all the sodium hydroxide has been consumed. That brings us to the end of part F. Make sure you don't skip part G, which are the post-lab questions. If you have any questions about any part of this experiment, please contact your instructor, although reading through the introduction to the lab will probably cover a lot of the potential questions you might have. Thank you.